This video is a demonstration of our project for our class on software-defined networking. The point of the application is to try and detect loops in networks, and it's based on a paper. It's based on a Unix paper. So what we need to first understand is how loops actually happen in the network. If you see the image in the bottom right, the normal image on the left basically shows, if you trace the arrows, you can see that there is no way that from any switch the path can lead back to the same switch. That is basically how you say that there are no loops. On the right hand side diagram, if you start at S11 and go up to S21, there is a path back to S11. So this is how a loop is detected in the network. We are going to try to aim to do this through an application. So to demonstrate this application, there are two controllers that we use. The first controller, it's an SDN controller written in Pyretic, which installs rules such that there are no loops caused in the network topology. And the second controller is such that there will be loops in the topology. I will show you the one without loops first. So you can see that this is insert no loop. This controller is up. I will then start the topology. This is a 4-switch topology, as you can see here, and it has 2 hosts. In order to correspond with this diagram, the topology is set up in the same way as these two diagrams. Now that the topology is up, you can see that the controller has detected the topology here. It has 4 connected lines here. Once this has done this, what we can understand from this is that there have been rules pushed into the switches, which can then be accessed by any other program. So we then run our loop detection program. So what this program does is it takes the flow dumps from the switches in the topology, analyzes the information in these flow dumps, and puts it into a form of an adjacency list, which is then analyzed for loops using Tarjan's algorithm. As you can see, there are two different messages given. The difference between them is the destination IP here. What the program does is it partitions the flow dumps that are in the topology depending on the destination IP. This is because if you have all your destination IPs in a single graph, it will sort of detect loops if it can't differentiate between which packets are going where. So now that we have partitioned based on the destination IP address, it checks the entire graph. It checks this graph to see if there are loops in the network or not, and then gives a message to the user saying no loop detected. And this is true for both our IP addresses 10.1 and 10.2. I will now show you a controller where a loop is put into the network, and this application will then be able to detect the loop, and it will give a message to the user. So let me restart the controller here. So I will insert loop. I will exit Mininet so that we can have a fresh start on this. And I will restart our topology. So again, you can see that the topology which was connected is closed and is reconnected. And now that a new controller is up connected to this topology, there will be new flow dumps which can be accessed by the detect loop program. I will run the same program again. And as you can see here, a testing topology for destination IP 10.1. At this point, it says a loop is detected between switches 4, 3, and 1. This basically uses the B diagram shown in the picture. I've just renamed the switches. It says that there have been loops detected between S21, S11, and S22, which is the same thing which we can see in the diagram. And it also tests topology for destination IP 10.2, and it gives a message no loop detected. So basically, this is the application's advantage, is that it can detect loops and prevent any traffic from never reaching its destination. Thank you.